All right, so it is 2 o'clock Central Time. I'm sure we'll probably have a few more people coming in here and there. I've had a few people arrive since the last time I mentioned myself, but my name is Tony Moore. I am the training manager here at Potter, and today we're doing a first of what we've never done before, which is kind of exciting, having one of our third-party vendors present their product, which again gives us the ability to present to our customers. I think it's a great thing. One thing I do want to say is if you guys have questions, please feel free to type those into the chat box. Myself and Gary, who's the other trainer, will be monitoring the chat box. And if we need to, we will get Chris involved and let him know that there's a question that needs to get answered. In addition to that, this is being recorded. Again, hopefully we will have this up on our website early next week, up in the past webinar section. Otherwise, I'm going to hand it over to Chris with Ditek.
Thanks, Tony.
No problem.
All right, guys. Well, good afternoon. Appreciate you taking the time to attend Ditek's Introduction to Surge Protection webinar. Appreciate Tony, Gary, and the other folks at Potter for involving us in this program. So again, I'm Chris Ross. I'm one of our field sales engineers. I've been with the company a little over 14 years, and I am going to be your guide into the exciting world of surge protection today. With that being said, we'll go ahead and get started here. So for those of you who might not be familiar with Ditek Surge Protection, I want to give you a little bit of a rundown of the company itself. We've led the industry in the design and manufacture of surge protection solutions for over 32 years now. We're located here in Largo, Florida. We're American-made, veteran-owned company. We're founded in 1988. We're ISO 9001 certified manufacturing facility, going on 14 years straight as one of Tampa Bay's top 100 workplaces. And we manufacture roughly 95% of our products right here in our factory in Florida. Here's a picture of our awesome team. We're 83 employees strong and proud to be made in the USA. And we eat and breathe surge protection. This is all we do. So, you know, a lot of our competitors, a lot of different divisions, if you will. But when you think of Ditek, you know, we are surge protection. Here's a quick little video of our factory floor. Give you an idea of a typical workday here at Ditek. So sometimes when you see our products, you know, they're little widgets, as some would describe. You don't really realize how much goes into the manufacturing process. So, you know, it is pretty advanced. We do encourage anyone, if you're ever in the Orlando or Tampa Bay area, you know, come by, we'll give you a factory tour and kind of show you the ins and outs of the operation. I think you'd be pretty impressed. So in general, what are surges and spikes? We're going to look at what they are, where they come from, and some of the Ditek solutions that are used to protect fire alarm systems. We'll touch on IP video, access control, intrusion, some of the other applications you all get into, which is, I know, is more than just fire, although fire happens to be our largest market. So surges and spikes are temporary increases in current and voltage in an electrical circuit. That's the simplest definition that we can come up with. And they can be present on any metallic conductor. So if you kind of imagine all of the copper or category cabling you have leaving a facility, whether it's burial or aerial, those are all vulnerable paths for a transient surge to jump on and damage the equipment inside the building. So these surges can damage, degrade, and even completely destroy your sensitive electronics. So what are surges and spikes? First and foremost, a lot of people go directly to lightning strikes because they are the most dramatic, but they're not the most common. What I mean by that is direct lightning strikes account for less than 2% of the equipment damage when you're talking about surges. What happens more often than not is a proximity strike. And what that means is it's kind of like an indirect lightning strike. If you have a specific facility anywhere and you took, say, a half-mile radius and drew a circle around that facility, and one of these summer or winter storms comes through and you count how many times lightning hits in that circle, it's going to be quite a few. But the likelihood of a direct strike to your customer's facility is very low. You also have surges that come from the power company itself by way of utility grid switching. This is when the power company or local co-op switches from residential to commercial loads and back and forth, and that's generating surges that are coming into the facility through the incoming power. So when that energy is generated, it does create a surge back onto the electrical grid of the building, if that makes sense. And then you have power that comes from brownouts, blackouts for areas of the country that might not experience a lot of lightning strikes. These brownouts and blackouts, anytime there's a sag in voltage from a brownout or blackout, it's immediately followed by a spike, which is considered a surge. And the most common causes of surges are generated from inside the facility itself, believe it or not, and they're called inductive loads. 60% of surge events that the facility experiences are generally from within that facility. One of the biggest culprits we see are printers, copiers, commercial printers and copiers, for that matter. Anything that draws a lot of current to cycle on and off is actually dumping that current and surge back onto the electrical system, thus affecting your sensitive electronics. So by no means is it's dramatic as a lightning strike, but it happens more often. You kind of think of inductive loads as that silent killer degrading electronic equipment over and over again, to where a device that should last 2 years, 3 years, 4 years ends up lasting a number of months. And then you also have mechanical failures, which does happen when equipment failure causes over voltage situations. And as much as we like to think it doesn't happen, human error. In some market segments we deal with, sometimes the field technician makes a huge mistake and induces 120 volts onto a data loop, and in some way, shape, or form crosses wires, ends up taking out equipment that way. So these are all causes of surges and spikes. What I want to show you here is, in talking about lightning, this is the entire US and the cloud to ground flash density map from Bisaya for the years 2008 to 2017. And the reason I wanted to show this is because we probably have attendees from all over the US in this training. And if you're sitting in somewhere like, let's say, Omaha, Nebraska, for example, which has some orange areas, Omaha gets on average over those years 12 to 20 lightning strikes per square mile per year. And just remember, it only takes one good lightning strike to take out your IP surveillance system, your fire alarm system, intrusion, etc. So this kind of gives you a gist of where the lightning is. Obviously down here in Florida where we are, it's nice and purple, where we're the lightning capital of the USA, but every state does experience lightning to some degree. Next, we're going to talk about some of the effects of surges and spikes. We call them the 3 Ds. So the first one you've got is degradation, which is the gradual deterioration of the electronic circuitry. This is more your inductive load, smaller surges that are kind of chipping away until your equipment fails one day, and out of the blue you wonder why it didn't last more than 18 months. And then you have destruction. So, which anyone doing fire, surveillance, security, life safety applications and installations has probably seen a circuit board with a char mark like this from a surge or spikes. And lastly, the most importantly, we have downtime. Now, this is the cost above and beyond the cost of replacing the equipment. So, just as an example, not on the fire side, but, like, let's say an IP surveillance system, it's in place for a reason, right? And that's to record the video. Well, if an event does occur and cameras were down due to surges and the NVR was taken out, and you cannot go back to that video, well, that missing video can prove to be priceless depending on the event that occurred when it was down. So it does come down to a liability issue at times. So how does surge protection work? It's relatively simple. You can kind of think of it as a pressure relief valve. Here's your typical IP camera with DC PoE here, and you have surge that comes along and induces on that Cat 5 or Cat 6 cable. And without the surge protection in place, it's going to travel right onto your equipment and most likely take it out, right? So once we have the surge protection in place, which is in series with the circuit, it now acts as a safety valve, so to speak. So now the surge, instead of going through to your equipment in either direction, can be safely diverted to ground, self-reset and self-restore, and wait for that next surge event to come along. So it's really simple in the functionality of it. There's no moving parts to our devices, and all of our devices are self-resetting and self-restoring. And talking about codes and standards, as far as fire, a lot of surge protection requirements are code-driven. Lucky for us, NFPA 72 and NFPA 70 typically deals with building-to-building runs and the requirement for a UL-listed surge device. And all Ditek devices, for fire, for example, are going to be UL listed. Some of the code references here, I won't bore you with every single one, but basically on NFPA 72, like I mentioned earlier, we're talking about, power limited or non-power limited signaling systems, circuits going building to building must or shall be provided with a transient protector, i.e. a surge protection device. NFPA 70 into the National Electrical Code 2007 kind of talks to the same thing as far as, building to building, outdoor runs, installation requirements requiring a surge protection device. And this, again, I won't speak to every single one, but the gist of it is there are codes in effect that will, that do require surge protection. And that's not a Ditek thing. That is a fire marshal authority having jurisdiction. I know every jurisdiction is probably different, whether they're enforcing these regulations or not, but it is required. As far as the AC power goes, this is more on your 120 volt protectors for UL 1449. Type 1 will be a permanently connected SPD intended for installation between the secondary service transformer and the line side of the service equipment or over current device. Type 2 are the SPDs installed on the load side of the service equipment. And then type 3 would be your point of use SPDs, such as a surge strip, just to give you an idea what that means. So these are all UL terms. And then the 497, 497A and B, that is more on the SLC loop, communication circuits, NAC circuits, for primary protectors for communication circuits, secondary protectors for communication circuits, and also your isolated loop protectors. So one thing I really wanted to show you here, being on the integration side, we have a what's called a surge refusal form. So anybody on the sales side, on the integration side, this acknowledgement of surge refusal form is, like I said in the beginning, it's often overlooked aspect of any life safety or security installation, but I can assure you, if any of us went down to Best Buy or one of the electrical warehouses and bought a $1,500 TV, you'd be hard pressed to take that TV home and just plug it straight into the wall. More times than not, you're going to buy a surge strip, maybe even a UPS, maybe like a wall mount wart protector to plug that device in. So, this surge refusal form is something that can help you in quoting or the proposal process, and it's more of a talking point to you and your customer to make sure the end user knows that something is available to protect their investment without finding out the hard way after something's already been damaged, and then you have to make a claim with their insurance company. So this is available in PDF or Word document. You can doctor it up, put your logo on it. We'd be happy to get an email off to get distributed to everyone on the training. So this is kind of give you an overview of all the different aspects of surge protection that we do manufacture. I know we're a little bit more fire centric on this call, but you guys are all doing more than just fire, and all of these types of solutions can all be purchased through Potter, not just on the fire side. So, just looking here, whether it's surveillance, access control, IT network type surge protection, exterior cameras, we even have a full line of electrical distribution surge protection devices that we manufacture. So, it's not just fire. We have a broad range of surge solutions that we do manufacture here in America. Now, as far as fire, give you a quick little overview. So it's pretty straightforward. So starting on the left, when we're talking about, SLC, NAC, anytime a circuit leaves the building, it's absolutely got to be protected by code. And we offer a device in the 2MHLP-B and 2MHLP-F series, which are both 3-stage hybrid devices featuring a diode, a gas discharge tube, and a fuse. On the F version for SLC protection, we use a 1 amp fuse. So that device, if that device were to self-sacrifice, that triggers that fuse to open up. So now you know exactly what devices aren't talking to each other. So it makes it a lot easier to diagnose for the service tech in the field, especially when you have several of these devices installed at, say, a garden-style apartment or a school-type setting. Over on the right, you'll see the external antenna kits, distributed antenna systems, DAS, maybe an antenna on the roof. These antennas are like lightning rods and should always be protected. Phone lines, POTS lines, there's still a lot of people using them, so we do offer a modular style with the MRJ31X device, or a hardwire screw terminal style with the 2MHTP series. And when you get to the bottom is where we've come a long way. That device on the right, the DTK120 HW lock, is still one of our top 3 selling devices and includes the NFPA 72 compliant circuit breaker lockout kit. But as a parallel device, parallel 120 volt AC protector, the only indication of the unit sacrificing is the LED indicator. So someone actually has to put eyes on that device. that is a very robust, economical UL listed 120 volt option. But the upgrade to that is going to be our new Deflector, the DF120S1. This is our new modular 120 volt protector, which is again called the Deflector. This guy's groundbreaking, patented technology. Not only is a 120 volt UL listed device, but it also features the UL 1283 listing for EMI and RFI filtering. So in addition to protecting the 120 volt circuit feeding the equipment, in this case probably going to be a fire alarm control panel, it's going to clean that power as well and get rid of any harmonics that you have on the line. So again, cleans the power, protects the connected equipment. The other cool thing about this device is if it ever does self-sacrifice, the Surge module is field replaceable. So not only does it feature the LED indicator, which is your first indication of the Surge device working or not working, it's also got a super loud audible alarm to let you know the device is sacrificed, in addition to the dry contact circuit. So there's 3 different ways that it can alert you, hey, I need to be replaced. Here's a cool little video to kind of show you how the replacement module would be replaced in the Deflector. So I can get it play here. So units in normal state, when the module sacrifices, the LED indicator turns red. It will also report to your panel. Now you'll turn the breaker off. Pop the module out. You'll pop a new module in. There's only one way that it will go in, so it's pretty hard to mess up. Restore power, and you're done. So it was at 45 seconds. So another cool thing is that you don't have to be an electrician to replace the module. So a spare module can be sold with the device and kept on hand at the location, at the point of use. So pretty cool design. We're really excited about this. And this is the kind of device that you might want to specify and install at, say, a home run panel. I mean, we wouldn't, I'd love for you to install one at every panel you install, but more or less this would be for your main fire alarm panels. New device we have coming out in a couple weeks. This is our new Deflector 120 by 12. So in addition to the 120 volt deflector at the top of the enclosure there, with the audible alarm, with the LED indicators, rapid replacement, dry contacts for remote notification, you're going to get up to 6 2-pair low voltage module slots. So in essence, this device will protect your 120 volt feed and 12 pairs of low voltage wiring for SLC, NAC, PIV, basically any 5 to 130 volt circuit, and you can specify these modules according to the voltage. So again, UL 1449 listed. It's got the filtering with the on the 120 volt deflector with the UL 1283. Just a really cool design. We're really excited to be coming out with this thing really shortly in the next few weeks. Look inside, see the wiring of this 120 by 12, and I'll talk about it a little bit later, but all of these CAD files or design files are available on our website. You can pop them right into your plans, and it makes it a lot easier on designing our devices into a system. There's a normally open, normally closed dry contact circuit to give you that third level of protection on the deflector or the 120 SRD, which is the other 120 volt device we manufacture. So this would kind of consider a smart 120 volt protector. But I don't know about you, but if I was a property owner, I'd much rather pay $70, $80 to replace a Surge module than $1,000 for a new board. Now the little brother of that deflector would be your parallel 120 volt protector, which is the 120 HW lock. Very robust, very small footprint. This device is UL listed as well and intended to go through a knockout of the fire alarm control panel in a 4-square box next to the panel or at the breaker feeding the alarm panel. So this device includes the NFPA compliant lockout kit to prevent any accidental disconnections of the fire alarm system. So really robust device, one of our top selling options. And In addition to the deflector and the 120HW, you know, like I said, the deflector maybe put at your home run panel, and you can use these 120HW locks at any of your secondary panels or booster panels. So this would be the TSS series. It stands for Total Surge Solution. We manufacture this series to be kind of a customizable solution for you, if you will. So in addition to the 120 volt protection, we can size these up accordingly to give you 4 pairs of low voltage protection on the left-hand side, or in the middle, the TSS1 will give you up to 10 pairs, kind of like the 120 by 12, but in a NEMA 1 enclosure, a lockable enclosure. And then we offer just the 120 volt on the right-hand side, top corner, or just the low voltage, all in NEMA enclosures that can be placed and installed adjacent to your fire alarm control panel. So on the security side, just to touch real quick, you know, a lot of people will ask, hey, you know, Chris, why do I need to protect on both ends? Well, best practices would require protection, say at the camera and at the head end, i.e. your switch. And that's so, you know, if surge is introduced on that circuit, it's going to look for the path of least resistance. So instead of the surge referencing your equipment, we want it to reference the surge protection device that's tied to ground, so that energy can be harmlessly dumped to ground, self-reset, self-restore. So we want our device to basically take all the jabs, all the hits from this excess energy and not your equipment, if that makes sense. So we want to be that sacrificial lamb. We want to jump on the grenade instead of your equipment. So hopefully that does make sense. Just to touch on IP video real quick, you know, whether it's your head end at your switch, NVR, or the single channel protectors out at the camera, we manufacture devices for all of these applications, indoor, outdoor rated, multi-port, single port, 24 port. We've got you covered in that regard. We do use RJ45, or excuse me, shielded RJ45 connectors now, all UL listed, all 10 gigabit speeds, which is the best in the industry. And our surge current rating, as far as the strength of our devices, in this case, 20,000 amps per pair. That's super robust. That's tops in the industry, and that's because of the technology and the components that we do use in the manufacturing process. Networking communication, you know, we've got a variety of different devices for, say, Cat6 circuits. We also manufacture UPSs, wall mount, Versa module series. Maybe you've got some rack mount equipment that you are terminating, RJ45, as well as maybe some analog cameras. We've got, you know, those types of solutions as well. And then as far as commercial and residential AV, we've got anything from line conditioners, you know, 70 volt speaker protection, et cetera. And we're gonna show you some pictures here in a minute of proper installs for our devices. So try not to focus on actual, you know, product too much or part numbers. Just if you take anything away from this, in addition to the variety of fire alarm surge protection solutions we've got, we also have a variety of different applications as far as, you know, access control, intrusion, CCTV surveillance, et cetera.
Hey, Chris, I'm just going to add one thing, if you don't mind.
Yeah.
I know you're on there as far as the RJ45 connections.
Mm-hmm.
So I was just going to add for people, if your equipment that you're using now is not using it, eventually it will use it. If you're not aware of it, you know, Potter is coming out with a network system here in the next month and a half, and one of those options for networking is going to be with an RJ45 connector. So while you may think that you're probably not using this now, there's a good chance that you're going to need something for this later on down the road, whether it's for our systems or whether it's for another system. So I think it's a great thing that they're introducing this, and it's perfect timing for us.
Absolutely, and you know, this would be probably the device that we would recommend, which is I don't know if you can, hopefully you can see it. I changed over my website real quick, but so the MRJ POS, don't let the shielded connectors on any of our network protectors fool you. These are totally compatible with shielded or unshielded cabling. So, you know, we try to make it easy. We wanted to kind of consolidate to one design, that being the shielded connectors, because it's a much better, just a connectivity design. As you can see, UL listed, whether it's the single channel unit, anything like a 4-channel, you know, we make a couple different ones in a very small footprint. So definitely something to keep in mind.
Nice. And one of the questions, while while we got a little break here, if you don't mind, was maybe getting an example for what to use for certain types of wiring scenarios coming out of our control panel. And I said, sure, we could probably put something together. So if you don't mind, I'll probably get with you, Chris, after this. And so something that people can look forward to is we'll send out an email, maybe with an example coming out of our control panel and saying, suggest using this for the P-Link, suggest using this particular device for the SLC, and then that one that you showed as far as our networking, use that for that. And even if it's not for our networking, maybe you're still just using the email capabilities of the control panel and some of those features, you could still utilize that particular device that he just showed coming out of our Ethernet.
Good point. Good point. And another thing I will mention, guys, whether it's our fire alarm protectors or video protectors or Ethernet, everything's passive. So our devices are basically unrecognizable on that circuit. They don't cause any resistance until they see a surge over 130 volts or 72 volts, whatever the case may be, depending on the product. So you're not going to have any kind of packet loss or anything like that. Something to keep in mind. And I don't know much about the P-Link, Tony, but I could definitely put together a bill of materials or the correct Ditek solution for that circuit once I know a little bit more about the voltage and the amperage and that type of thing.
Yeah, and that's why I'm saying we can get together afterwards and iron all that out, and we'll send an email out to all the participants on this webinar.
Perfect. Yeah, and just to touch really again, whether UPSs, hardwired Cat6 protection, we've got you covered there. Gate access, I'm not sure if anyone on this call would get into gate type access applications, but all of these parts, they're not fire, but they can still be ordered through Potter. Gate motor, any kind of telephone entry, etc. Same with intrusion. Not a huge market for us, but I at least wanted to show one slide and say, hey, we still make some of these, I don't want to call them legacy, but they've been around for a while. And something that might make sense here. So in selecting the correct Ditek model, when you call Ditek, you get a live voice during business hours. We have a technician that carries a cell phone 24/7. So we do have 24/7 tech support, English speaking. What we will ask you is say, hey, Chris, what do I need to protect this SLC loop or this NAC circuit? So generally it's going to be a 24-volt circuit. I know that. But what we're trying to do is size the surge protector according to the maximum continuous operating voltage of the system. So on a 24-volt system, you're going to use a 24-volt surge protector, but that surge protector doesn't clamp right at 24 volts. By design, we want to let a little bit of excess voltage through that protector so we're not cutting that signal too soon, and at the same time, we want to clamp it soon enough so we're not clamping it too late to where it has already caused damage to the connected equipment. So for instance, on this 24-volt protector, which you would use on NAC circuits, SLC loops, maximum continuous operating voltage would be 33 volts, and then we're going to turn on at 39 volts. So that's kind of the rhyme and reason. All protection modes are all lines are protected, all pins are protected, and that surge current rating of 20,000 amps, tops in the industry. And again, that's achieved because of the multi-hybrid design. We use different components that complement one another, if that makes any sense. Same for a speaker circuit, whether it's a 70-volt speaker, we make a 75-volt low voltage protector, same philosophy. We're in master spec now, so division 28, if you're familiar with master spec, covers fire and life safety. So my job is to call on engineering and A&E firms and get our devices specified in on large projects, which makes our integrators' life easier because they can just bid on the projects and the parts are already there. But just know that we are in this type of this master spec program on the engineering level, and our parts are in there by part number. A look at some of the fire alarm A&E design drawings that we have available on our website. It's actually in our portal. We have an engineering portal which I can get anyone access to. I just need to get your email and I'll send you a username and password. But excuse me, unlock PDFs, A&E specs, CAD files, basically drawings like this that you can just drop right into your plans and not have to reinvent the wheel as far as the surge piece goes. There's also, I thought it was the next slide, but there's at the bottom some bullet points that speak to wire gauge, grounding, that type of thing. So we try to make it as easy as possible on you. And some of the best practices here, bear with me. So we want to make sure that our devices are installed correctly, because the last thing we want you to do is call us up and say, hey, you know, Chris or whoever you're speaking to, you know, we had your MHLP installed on an SLC loop, it didn't work. Well, we're gonna have a lot of questions for you as far as how did you ground it, how long were your wire links from the surge device to your equipment, and some of those best practices would involve the 3-foot rule. So I know it's showing a camera installation, but this holds true with any of the fire alarm protectors as well. So we want to see a minimum of 3 feet conductor length. What I mean by that is 3 feet from the Ditek protector to the equipment we're protecting. That gives the device enough time to turn on and react, because you know it does take time to turn on, even though it's nanoseconds. So that 3 feet allows the device to turn on before the surge gets to the equipment, pull that surge back to ground, and again, self-reset, self-restore. So what you're looking at now is incorrect. You know, what you're looking at is basically a $60 coupler. That's a pass-through. It's not even grounded, and they're using about a 2.5-inch patch cord. So ideally, what you would want to do is make yours look like the installation on the right, where you've got your single-channel Ethernet protectors, and then probably about a 7-foot patch cord going into that Netgear switch, and then each individual Ditek unit is grounded. You can't see it, but behind there is a ground bus. Speaking of ground buses, we do recommend the use of a ground bus. Strongly recommend it as a means to terminating your ground leads. This will ensure a mechanical connection. We don't like wire nuts. It's not against code, but as a manufacturer that's been doing this for 30+ years, you can have corrosion. You know, somebody could bump their elbow up on a wire nut and knock it loose that way. So it's just a much, I think you'll agree, cleaner install, much more mechanical install when you've got a scenario like the one on the right instead of the scenario on the left. So again, not against code, a strong recommendation. Our devices are going to work better as they're designed and engineered to work when you have a good mechanical connection to ground. And one thing I'll also add is, see how they've got this thicker gauge ground coming into earth ground coming into this bus, and then you've got, you know, looks like a number 12 coming off the Ditek device onto the bus. That's perfect. We want to give you a large dumping point. So the larger gauge ground you can use, the better. Most of our devices are going to take number 10, 12, and then again, using the larger gauge into the bus is a good practice. The third installation rule just talks about daisy chaining. So here you've got some low voltage SLC loop protectors, it looks like. So what they've done is they've daisy chained the ground wire from each Ditek device to each device, whereas we actually want to see an independent ground wire going to each from each device to the ground bus. And actually that's what they've done here. So this would be a good photo. So see, there's 4 protectors, there's 4 ground wires going to that ground bus. That's perfect. You want to avoid any daisy chaining like this. So left is bad, on the right is correct. And then it's pretty good installation rule for fire. We always want to make sure that your protected or unprotected wiring goes through different conduit. That way you can't have any induced voltage if they're going through the same conduit. You know, because that energy can be induced from the protected wiring to the unprotected wiring, and we want to completely bypass that scenario. So kind of give you an indication of what not to do. You know, on the left, all the wiring is going through the same conduit. On the right, separate conduits up top, bottom, unprotected, protected. That's a really good install there. We never want to see our devices installed inside of a fire alarm control panel like that. So I think you can agree that that's a very ugly install. We want our devices adjacent to the panel with either an enclosure that we provide you, like that TSS series we talked about earlier, or your own trough or enclosure. So that's perfect. On the right, they've got the bus, they've got the earth ground coming into that bus with the lockable looks like a lockable can there. So our number one 120 volt protector is the 120 HW lock. Here's a little diagram, and keep in mind that these diagrams, these install instructions come with every Ditek device in the packaging. A lot of the field techs will throw these out right away, which I get, but like I said, we try to make it as easy as possible for our devices to be installed correctly the first time. You can see where we talk about the 3-foot conductor length. This would actually happen to use a terminal strip inside the fire alarm control panel. So in this scenario, we want you to cut our leads as short as possible, land that hot ground neutral on that strip, on the terminal strip, and then your 3 feet is the black wire achieved right here onto the circuit board of the fire alarm control panel, and then ground and neutral as well. So when I say 3 feet, I'm talking about the actual black wire, the hot wire. And if you wanted to install it in a junction box adjacent to the fire alarm control panel, that's right there as well. And then the third scenario would be installing the 120 HW right at the circuit breaker, the breaker panel, the circuit breaker feeding the fire alarm control panel. So all three are fine. People tend to lean towards installing it at the point of use, i.e. right at the fire alarm control panel. And we've had customers take it a step further, install the 120 protector at the fire alarm control panel and at the breaker box. So you got a couple different scenarios there. The 3-foot rule doesn't really come into play when you're talking about installation at the breaker feeding the panel, because you're going to be more than 3 feet away from the fire panel anyway. On the network side, just indicates, these are longer than 3 feet. We like the longer than 3 feet patch cables to give the device enough time to turn on and react. Picture of a camera install, base of a pole. They've got an enclosure where they've got that single channel Ethernet protector right there, grounded, perfect install. Here's what sorry, we can get a Potter picture in here. We'll have to get one of those from you, Tony. But here's what the TSS series would look like installed next to, I'll just call it a fire alarm panel. So you can see it's pretty clean install. You've got protected, unprotected wiring going through separate conduits. It's lockable, it's clean. You can even put your company logo on there for you if you wanted to.
Maybe we'll put a challenge out there to some of the people on this call that next time they put a Potter system in and install a Ditek, send us in a picture with conduit that's hung a little bit straighter than that in this particular photo. And
yeah, I mean, we love getting pictures of our products installed, especially next to Potter panels.
And it'd be a great, and even then, so stuff like that. So while you guys are on the line, we like doing white papers, case studies. I can't guarantee it'll happen, but it's one of those things of, if you send it in, send some pictures, send some information behind the install. Sometimes our marketing group will actually write up a paper, which will then get distributed with your company name, everything else about the install. It's going to include Ditek information. It's going to include Potter. But it's good for you guys, and it's good PR for us as well. So
great, free advertising.
Yeah, anytime you guys have something like that, I mean, by all means, send it over.
Same thing here. This is an enclosure that was installed adjacent to the fire alarm panel, protecting all the low voltage wiring. Really clean. You achieve the 3-foot rule there. Use of a ground bus. I know it sounds like a broken record, but it's really important. Installation and grounding of these devices is really 99% of the battle. And we get calls on a daily basis, on an hourly basis, of folks installing our products incorrectly. So it's a constant education, whether I'm out in the field, in Texas or Oklahoma or wherever I'm traveling. If COVID wasn't going on, I'd be traveling. But the case, what I'm speaking of is it's just a constant education of proper installation of these devices, and not just ours, but surge protection in general. I think it gets installed incorrectly a lot more times than not. Here you got the smart 120 volt devices all in an enclosure. This is a pretty high tech install here, protecting 6 different 120 volt feeds for the FACPs. Good looking install. This is actually a picture I took at a large elementary school in New Orleans, where they've protected all of the intercom circuits coming back to the kind of like right there by the principal's office in the front office. They also utilize the UPS that we offer at the bottom of the enclosure there. I saw a question come through. Let's see. Is it okay to use the 110 volt AC ground wire for the surge protector, or do you have to go to the building ground? No, we would prefer and recommend the quote unquote house ground or 120 volt ground. So you always want to try to use the same ground that the panel is using for any of our surge devices. So that's a great question. Yeah. Building steel is another source for ground, as well as an independent ground rod. But anytime you can grab the electrical ground of the building, that's always going to be your best source. Great question. And to give you a little idea, you know, as far as electrical surge protection, these are main distribution panels outside. It may not be in the scope of what you do, but just kind of shows you what we're capable of and some of the other solutions that we do provide. We do offer, I will tell you, site surveys, free site surveys, where we come out, walk your site. We can test grounds with our clamp-on resistance meter or a megger, depending on what kind of grounds you have, whether they're tied to the electrical ground of the building or they have independent ground rods. So just keep that in mind. We're not doing much of it right now. We are down here in Florida, but once COVID's through and we can get off this wheels down, which we're dealing with right now, we'll if you've got a problem site, give us a call. We're happy to meet with you in person and try to rectify the issues that you're having. And this is one of the tools that we do use. This would be used for grounds that are tied to the building electrical system. This is called a clamp-on resistance meter. It's about an $1,800 tool, so they're not cheap, but we've got a few of them that we use as a traveling field sales group. And then the megger would be used for when you've got independent ground rods. Some of the ground references we talked about earlier. So concrete encased electrode, metal building frame. The concrete encased electrode is basically your building steel. I'm sorry, is basically your electrical ground of the building. The metal building frame would be your building steel. And then you get into independent ground rods and that type of thing. So per National Electric Code, we want to see 25 ohms of resistance or less at ground. IEEE calls for less than 5. So anytime you're 5 or under, you're golden as far as ground goes. And like I said earlier, 24/7 tech support. DitekSurgeProtection.com. We've got that engineering portal where you're going to find any of the unlocked data sheets, ANI specs, CAD files. You know, I cover the Gulf Coast region, but there's 8 of me here. So whether you're in California or Florida or Maine or New York, you know, we've got, and I'll get the I can get the map out to Tony and Gary and some of the other you know, Potter account managers who know who to reach for any questions that we might have. And again, we aim to please. So if we can make your life any easier, you know, I wouldn't just sit on the website and scratch your head. Hey, you know, does Ditek have something that'll protect this equipment or this piece of, you know, wiring with this amperage and this voltage? Just call us up. This is all we do. This is our bread and butter. You know, I've been here almost 15 years. There's folks that have been here a lot longer than me. I'm kind of one of the guys that has been here the least amount of time. That gives you an indication of the kind of turnover we have here. But we're a family-owned company, and you know, we're happy to have Potter on board now, and can't say enough good things about working with those folks in the year or so that we've been doing so. So if you guys have any other questions here, I'll open up the message deal here, but I'm gonna give you my contact info, and if I don't cover your particular territory, I can get you into the right spot. Hopefully we didn't put you to sleep. Look at that, 45 minutes, 44 minutes.
It's awesome.
But yeah, a lot of information available on the website. But again, you know, we've got a team here that you're going to get a live voice when you call during business hours, which are 8 to 5, actually 8 to 5:30 Eastern. And And then if we can't answer it, we've got a guy carrying a cell phone on Sunday morning at 7 a.m. or Friday night at 9 p.m. If you've got an install that's running late or really early on the weekends, give us a call. The number's on every device that you buy from Potter. There's an 800 number on there. That's the tech support line. And we're happy to lend a hand. And again, we want to make sure you guys are installing these things correctly. So last thing we want to do is get a call saying, hey, my equipment blew up. It's your fault. What happened?
Yeah. And I went ahead and put Chris's email address in the chat box there. A lot of times I don't know for him, I know for me, a lot of times the best way to get a hold of us sometimes is via email, just because if we're in different trainings, things like that, it allows us a better opportunity to get back to you, especially if you put your question in that email, we'll at least be able to do a little ground searching prior to giving you a call back.
Awesome. Thanks,
Chris.
Tony.
One of the questions here, they want to know if possibly your presentation would be available.
Yeah, I mean, I guess you recorded it, but if you go to diteksurgeprotection.com, and I don't know if you can see what I'm doing here right now, but we've got a little webinar header, right? So we've got one on here. It wasn't made by me. It was actually made by my boss, Jason, but the same information was covered. In fact, a little bit more in depth, if you will. So that's available right there. And yeah, so I guess the answer is yes. It's just you won't hear my voice. You'll hear somebody smarter than me. But as far as you guys recording it, like you said, Tony, it's going to be available on the website to any of your dealers.
Correct. Yeah, we'll actually have that up in our past webinar section, and the goal is going to be to have that up early next week, barring no issues.
Yeah, and folks, keep in mind, as far as if you would like a training like we just did today, specific to your team, whether it's at 7 in the morning to get your guys out on the road, we can do webinars for you individually. You know, we're just trying to educate you and get you to buy more through Potter. So let us know. We'll get you set up, and we're, you know, with a lot of us not traveling as much as we used to, our schedule's a little bit more wide open now that we're all working from the factory here.
Yeah, and I'll admit, I don't know for people on the webinar whether they would admit it. So again, I did come from the field. I'll admit I never really knew the 3-foot rule, and there's a few times I did put some of your Ditek Surge protectors within 3 feet of the particular device I'm supposed to be protecting, which obviously is wrong. So I came out with some information from this, which is good. And for that 3-foot rule, it kind of plays in nice to the fire alarm industry, because a lot of times if we're controlling something, we're supposed to be within 3 feet of that. So I would think the 3-foot thing would come fairly easy to the fire alarm world.
It should, and just keep in mind that's 3 linear feet. We're talking wire distance, so a lot of people, I'll get a call saying, "Hey, this fire marshal is telling me I got to be 3 feet from the panel." No, I mean we make the device to butt up right against the panel knockout of the panel. We want to see the 3 feet of wire inside the panel, so it's fine. I mean you can put it 3 feet away, but we're actually talking about linear distance. But no, to your point, Tony, there hasn't been a training that I've given in my almost 15 years here where I talk about the 3-foot rule and somebody doesn't look up with like bright eyes like, oh no. I'm just thinking I'm talking as the guy I'm looking at like, oh my God, all the installs I've done, I've never followed this protocol.
Yeah, I would be honest, if my camera would have been on, that's the exact look would have been on my face. Like, oh man. And I don't know if anybody else would admit to that on the call, but yes. So I know Chris is pretty much done with his presentation at this time. Again, Chris, definitely appreciate this. Taking time out of your day. It's awesome. We have one person saying it's in the install sheet. Now, come on, who reads the install sheets? Because I know if you guys call into us for tech support, we'll say it's on the install sheet, and a lot of people will be like, "Oh, we never saw that." So I'm just messing there.
And I'll get with you on that P-Link question, you know, learn a little bit about that, and I can put together the parts list that would protect that particular piece of equipment or circuitry. Yes,
and again, we'll try and send that out sometime. Depending on Chris's schedule, I know he's busy tomorrow and stuff like that, but we'll try and get that sent out by early next week as well, letting you know what all particular Ditek Surge devices to use with the Potter system, whether it be on the SLC or whether it even goes to our new peer-to-peer networking using RJ45 connectors.
Perfect. All right, folks. Well, hey, really appreciate the time. Any questions? You've got our contact info. Give your account manager a call. They'll call me. Call us directly. We don't sell direct to dealers, so you can only buy our products through, in this case, through Potter.
Awesome. Again, appreciate it. Everyone on the line, appreciate it. Again, contact us, and if you have any questions, not a big deal. We do have one. So for this particular person, again, Mitchell, contact us. We can get you in touch with Chris, or again, it's chris.ralston@ditekcorp.com, and he can get you he can help you out or probably get you in touch with depending on what area of the U.S. you're from, he can get you in touch with the correct sales representative.
There we go. And I put my direct line on there as well on the reply. So. All right. Well, thanks again, Tony. We'll be talking later today or tomorrow, and just kind of go from there. Thanks, Gary, for on.
All right. Thanks, guys. Have a good one.
Take care. Thank you.